Here we're going to look at the 2015 ordinary level paper. It's question 2 and we're just going to have a look at the calculations. So it's the titration calculations we're looking at here. So it was found by titration that 25 mils of the 0.05 molar solution of sodium carbonate required 22.7 mils of a hydrochloric acid solution for neutralization according to the following balanced equation. Find the concentration of the hydrochloric acid solution in moles per litre. So we're going to start off by first identifying which numbers belong to which chemical. So it was found by titration that 25 mils of the 0.05 molar solution of sodium carbonate. So that's all talking about the one solution. And in our equation, there's our sodium carbonate. Now if we look for another solution here, so 25 mils of the 0.05 molar solution of sodium carbonate required 22.7 mils of a hydrochloric acid solution. No other numbers there, but I can highlight my HCl. Now that I have all of the numbers involved associated with a chemical, so they've all been matched up, I can now go to begin filling in my formula. So first of all, I'm going to just have my acid, which is HCl. I'm going to have my base, which is sodium carbonate. And do we know the concentration of the acid, M1? So if we look at all the pink highlighted there, there's no concentration, so no, I don't know that. That's what I'm asked to find. Find the concentration of the hydrochloric acid. Do I know what volume of acid we used? So from the pink again, because that's to do with our acid, yes, I've used 22.7 centimeters cubed. And then N1, so that's the number in the equation on front of the acid. So the number of moles. So if we look at our equation, there is a 2 in front of the HCl. So we put a 2 there. Then onto our base, our sodium carbonate. Do I know the concentration of my base? So M2. I do. There's a concentration. 0.05 molar or moles per litre. Do I know what volume of base I'm after using? I do. In the yellow again, 25 mils. And then I need N2 as well. So N2 is the number in front of sodium carbonate in the equation. And because there's no number there, that means we have a 1. So N2 is 1. Once all that's finished, then I can actually write down the formula. So M1 V1 over N1 equals M2 V2 over N2. And I just substitute in my values. So M1 I don't know, I'm going to leave it as it is, times V1, which is 22.7, all over N1, which is 2, equals M2, which is 0.05, times V2, which is 25, all over 1. Now, so what I can do there is, hold on, 25 times 0.05, all divided by 1. I can say that M1 times 22.7 all over 2 equals 1.25. I just worked out what this whole right hand side works out to be. Now this 2 that's underneath the fraction, I can bring that up and it will multiply. So M1 times 22.7 equals 2 times that right hand side, which is, 2.5. And now to get M1 on its own, this 22.7 was multiplying on the left, so when I bring it across it will divide. So divide the right hand side by 22.7 and we'll get 0.11 moles per litre. And that answer to this form, when you use this formula and you find a concentration, it will always give you your answer in moles per litre. It will always be those units. So that's us finished. That is our moles per litre concentration of our HCl found.